February 20th, 1943. A landing strip at Pacino Airfield, southeastern Sicily. Lieutenant Colonel Dan Story felt the damaged consolidated B-24 Liberator, call sign Blonde Bomber II, shudder as its wheels touched Italian-controlled soil. Through sheets of rain that hammered against the cockpit glass, he had mistaken this enemy airfield for the British fortress island of Malta, believing salvation lay just beyond the storm. Instead, capture awaited. Within minutes, Regia Aeronautica soldiers swarmed the aircraft, while Story and his 10-man crew emerged with hands raised. The bomber, serial number 41-23659, carrying the distinctive desert pink camouflage scheme of the 12th Air Force, had just become the first intact B-24 Liberator to fall into Axis hands. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What German technical intelligence officers would discover during exhaustive examination of this captured bomber at the Luftwaffe's secret evaluation center at Rechlin would shake their understanding of American industrial capacity, or more profoundly than any battlefield defeat. The Americans cannot possibly manufacture such complexity in these quantities, German engineers initially assessed. Yet, as months passed and more captured Liberators arrived for analysis, the evidence became undeniable. The defensive firepower concentrated in a single B-24, when multiplied across the thousands rolling off American assembly lines, represented industrial mobilization on a scale Germany could neither match nor counter. The transformation from combat aircraft to intelligence prize had begun hours earlier on that February morning at Tobruk Airfield in Libya. Story and his crew, along with 26 other B-24 Liberators from the 98th Bombardment Group, had taken off shortly after noon for a bombing mission against Naples Harbour. The 98th, nicknamed the Pyramidas for their North African operations, specialized in strikes against Axis supply lines across the Mediterranean theater. The mission started routinely enough, but weather turned savage. A massive storm front engulfed the formation before they reached their target. 24 bombers from the group turned back immediately, their pilots recognizing the danger of penetrating such violent weather. Story pressed on with the remaining aircraft, emerging from the storm just before sunset to find Naples Harbour below. The defensive anti-aircraft fire erupted immediately. German 88mm guns and Italian coastal batteries filled the sky with explosive shells that burst in black clouds around the approaching bombers. Blonde Bomber II released its bomb load through the maelstrom of flak, then turned for home. But enemy fire had found its mark. One of the 4 Pratt & Whitney R1830 radial engines began losing power, trailing smoke from damaged cylinders. Fuel gauges showed worrying drops in pressure from punctured lines. The bomber fell behind the formation, unable to maintain speed, with 3 engines operating at full power and 1 barely functioning. Story faced impossible mathematics. The distance back to Tobruk measured more than 500 miles across open Mediterranean waters. His crippled bomber could not maintain the altitude or speed necessary for such a journey, with damaged engines and fuel leaking from punctured tanks. The other B-24 seconds continued toward Libya, unable to slow down without making themselves vulnerable to the few German and Italian fighters that might still be aloft despite the deteriorating weather. Malta offered the only realistic option for survival. The British fortress island lay approximately 100 miles southeast of Sicily, close enough to reach even with failing engines, and its garrison would provide safety and medical attention for wounded crew members. But the storm that had plagued their mission continued, reducing visibility to near zero. Rain hammered the cockpit, wind buffeted the heavy bomber, and clouds obscured every landmark. Story navigated by dead reckoning, trusting his instruments and his navigator's calculations as darkness fell completely. When breaks in the clouds finally revealed ground below, the crew spotted what appeared to be a suitable airfield. The strip showed no activity, no anti-aircraft fire, no searchlights probing the sky. In the darkness and confusion, it appeared safe. The massive 30-ton bomber descended through the storm, gear extended, flaps deployed for landing configuration. Story brought the aircraft down with considerable skill, despite his damaged engines and the violent crosswinds. The wheels touched pavement, spray from standing water fountaining behind them. The B-24 rolled to a stop. Only then did the crew realize their catastrophic error. This was not Malta. Italian soldiers and ground personnel emerged from buildings surrounding the airfield. Regia Aeronautica markings adorned structures barely visible through the rain. Story and his crew had landed at Pacino, the southernmost airfield in Sicily, firmly in Axis hands. Story immediately attempted to restart engines and take off before Italian forces could respond effectively, but the rain had transformed portions of the airfield into mud. The B-24's wheels sank into soft ground, preventing the aircraft from building sufficient speed for takeoff. Within moments, Italian soldiers surrounded the bomber, weapons drawn. The crew had no choice but to shut down engines and surrender. For Story and his men, capture meant interrogation, then imprisonment in Italian prisoner of war camps, but for the Regia Aeronautica technical staff who immediately descended on the intact bomber, this represented an intelligence windfall of extraordinary value. Most downed Allied aircraft arrived as wreckage scattered across fields and forests, their secrets buried in twisted metal and burned components. But Blonde Bomber II sat virtually undamaged on Italian soil, a complete example of the most advanced American heavy bomber design, ready for detailed examination. Italian intelligence officers recognized immediately what they possessed. This was not just another crashed bomber to strip for salvage metal. This was the first B-24 Liberator to fall into Axis hands in flyable condition, offering unprecedented opportunity to understand American heavy bomber capabilities, design philosophy, construction methods, defensive armament, and operational doctrine. Within days of capture, Italian technical specialists began preliminary examination at nearby Catania airfield. Engineers photographed every system before touching anything, documenting the bomber's configuration exactly as captured. They measured dimensions, recorded equipment positions, sketched structural details, and compiled comprehensive technical reports on every visible feature. The challenge arose immediately regarding fuel. Italian aviation gasoline proved incompatible with the high-octane American engines. Captain Giovanni Reno, selected for his experience with captured aircraft, flew the B-24 from Pacino to Catania, using remaining American fuel in the tanks, then waited while Italian authorities arranged delivery of German aviation gasoline compatible with the Pratt & Whitney engines. Testing began at Guidonia Airfield, the Regia Aeronautica's primary experimental facility located northeast of Rome. For nearly 3 months, Italian test pilots flew Blonde Bomber II repeatedly, evaluating performance characteristics, flight handling, and operational capabilities. Engineers disassembled selected systems for detailed analysis, studying American approaches to hydraulics, electrical systems, turbocharger installation, and fuel management. What emerged from these Italian evaluations was preliminary understanding of American manufacturing philosophy that differed fundamentally from European aircraft production. The B-24 demonstrated mass production techniques optimized for volume output. Standardized components meant parts manufactured at different factories would fit together without custom work. Simplified assembly sequences reduced skill requirements for workers. Interchangeable parts allowed rapid field repairs. Everything about the bomber indicated industrial capacity operating at unprecedented scale. Italian technical reports noted particularly the defensive armament. The B-24D model carried 10 Browning M2 machine guns of half-inch caliber, positioned to provide overlapping fields of fire across nearly every approach angle. The nose featured flexible guns operated by bombardier and navigator. A Martin power turret mounted directly behind the cockpit carried 2 guns with excellent visibility and traverse. The Sperry ball turret beneath the fuselage provided complete lower hemisphere coverage. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Waist positions on each side allowed engagement of beam attacks. The tail turret commanded rearward approaches. This concentrated firepower exceeded anything Italian or German bomber designs incorporated for defensive purposes. Italian bombers typically relied on fewer guns of mixed caliber, often improvised and limited in traverse. The Savoia Marchetti SM-79, Italy's primary medium bomber, carried perhaps 4 or 5 defensive positions with machine guns of 8mm caliber. The B-24D carried 10 half-inch caliber weapons, each round delivering significantly more kinetic energy than European rifle caliber ammunition. But by spring of 1943, as Allied bombing of Italian industrial centers intensified, Guidonia Airfield became increasingly exposed to attack. American B-17 flying fortresses and B-24 Liberators struck Rome and surrounding facilities repeatedly. German military authorities, aware through intelligence channels that Italian forces possessed an intact captured B-24, requested transfer of the bomber to Luftwaffe control for more comprehensive evaluation at Rechlin, the Reich's premier aircraft testing facility. Diplomatic negotiations ensued between the two Axis partners. The Italians had captured the prize and conducted initial evaluations, but German technical intelligence possessed more sophisticated testing facilities, more experienced evaluation pilots, and greater industrial capacity to exploit whatever lessons the captured bomber might reveal. After weeks of discussions, Italian authorities agreed to transfer Blonde Bomber II to German control. On June 19, 1943, Captain Reynaud climbed into the cockpit one final time, accompanied by 2 Italian mechanics and a German crew. The flight from Guidonia proceeded through Munich to Rechlin in Mecklenburg, approximately 50 miles north of Berlin. The bomber received German national insignia during transit, large black crosses marking the wings and fuselage, swastika adorning the tail. The distinctive desert pink camouflage of American operations in North Africa remained underneath, creating a surreal visual contrast between American paint and German markings. When Blonde Bomber II touched down at Rechlin after its circuitous journey from Sicilian capture through Italian custody to German control, it entered the most comprehensive aircraft evaluation program in the Third Reich. Rechlin served as the Luftwaffe's equivalent to the United States' Wright Field in Ohio or Britain's Royal Aircraft Establishment at Farnborough. Every captured Allied airplane that could be repaired to flying condition eventually made its way to this facility. The testing center employed hundreds of technicians, engineers, test pilots, and support personnel dedicated to understanding how enemy aircraft worked and how to defeat them. Multiple grass airfields spread across the flat Mecklenburg countryside allowed simultaneous testing of numerous aircraft types. Hangars housed sophisticated measurement equipment, test stands for evaluating engines and systems, wind tunnels for aerodynamic analysis, and workshops equipped with precision tools for detailed component examination. Hans-Werner Lerche, the Luftwaffe's most experienced test pilot of captured Allied aircraft, had just completed extensive evaluation of the first intact B-17 Flying Fortress captured months earlier. That bomber, nicknamed Wolfhound by its American crew, had revealed much about American heavy bomber design and defensive tactics. Now Lerche would compare the B-24 directly against the B-17, understanding how American industry had developed 2 competing designs to fulfill similar operational requirements. Initial examination of Blonde Bomber II began immediately upon arrival in June 1943. Teams of specialists descended on the aircraft before engines cooled, beginning systematic documentation of every detail. Engineers removed inspection panels to study structural design, marveling at aspects of American manufacturing philosophy revealed in the bomber's construction. The wing proved particularly noteworthy. Davis wing design, developed by aviation engineer David R. Davis, featured high aspect ratio and specialized airfoil section that provided exceptional fuel efficiency. The wing's shoulder-mounted position atop the fuselage created distinctive slab-sided appearance that earned the B-24 its unofficial nickname, Flying Boxcar. But the aerodynamic efficiency was undeniable. German aeronautical engineers measured wing sections, analyzed load distribution, tested structural strength under various conditions. The wing gave the Liberator crew's performance superior to the B-17 Flying Fortress, despite carrying heavier bomb loads. Maximum speed approached 300 miles per hour at altitude. Service ceiling exceeded 30,000 feet. Range with standard fuel load measured over 2,000 miles, sufficient to strike targets deep in German-controlled territory and return to bases in England or North Africa. But efficiency came with trade-offs that German test pilots would soon discover. The Davis wing performed superbly at high speed and altitude, but exhibited poor low-speed handling characteristics. Stall speed was higher than B-17. Recovery from unusual attitudes demanded more pilot skill. Formation flying required constant attention. Landing approach speeds exceeded those of other heavy bombers, making emergency landings more dangerous. The fuselage construction revealed American mass production philosophy even more clearly than the wing. Where German aircraft required skilled craftsmen to hand-fit complex components through labor-intensive processes, the B-24 used standardized modules that semi-skilled workers could install rapidly using jigs, templates, and fixtures. The bomb bays, two separate compartments divided by structural supports, demonstrated this modular approach. Each bay could accommodate up to 8,000 pounds of ordnance, though rarely did so as maximum bomb loads severely reduced range. German engineers examining the bomb bay construction noted numerous detail differences from Luftwaffe practice. American designers favored straight structural members wherever possible, simplifying manufacturing and reducing production time. Standardized fasteners throughout the aircraft meant fewer specialized tools required for assembly or maintenance. Access panels provided easy reach to critical systems, facilitating field repairs. Every design decision reflected prioritization of production volume over perfection of individual components. The defensive armament system received exhaustive attention from German technical staff. Understanding the B-24's weapons suite became highest priority for Luftwaffe tactical planners. Every German fighter pilot facing American bomber formations needed to know the Liberator's blind spots, angles of approach offering best chance of survival, ranges where German weapons could engage without entering the lethal envelope of American machine guns. The numbers alone sobered German planners who understood implications. The B-24D model before them carried 10 Browning M2 machine guns of half-inch caliber positioned to provide overlapping fields of fire. Later, H and J models entering service in summer and fall 1943 would maintain similar armament with improvements in turret design and nose protection. 10 heavy machine guns represented firepower exceeding anything German bomber designs incorporated for defensive purposes. The Heinkel He-111, Luftwaffe's standard medium bomber, typically carried 6 or 7 machine guns of mixed caliber, many of them rifle-caliber 7.92 mm weapons with limited effectiveness against attacking fighters. The Junkers Ju-88 fast bomber might carry 4 or 5 defensive positions. The B-24D carried 10 half-inch weapons as standard equipment. Each half-inch BMG cartridge fired by these weapons delivered approximately 3 times the kinetic energy of German 7.92 mm rounds, and energy comparable to German 13 mm heavy machine guns. The half-inch round could penetrate armor plate, destroy engines, shatter canopies, and kill pilots from ranges exceeding 600 yards. German test pilots at Rechlin spent weeks examining each gun position, understanding fields of fire, traverse limits, and blind spots. They climbed into the nose compartment where bombardier and navigator manned flexible guns mounted in sockets cut through the plexiglass. Early B-24D models, like Blonde Bomber II, featured greenhouse nose construction with multiple glazed panels, providing excellent visibility for the Norden bomb site, but limited gun positions to manually operated flexible mounts. The bombardier occupied the forward position, responsible for accurate bomb delivery through the sophisticated Norden sight, while also manning nose guns when German fighters attacked. The navigator sat slightly behind and to the side, managing course calculations and position fixes while doubling as gunner during combat. These dual duties created workload challenges that German evaluators noted as potential vulnerabilities. The Martin-powered turret positioned immediately behind the cockpit impressed German engineers with its sophisticated design. Two half-inch machine guns mounted in electrically operated rotating turret with hydraulic elevation controls provided excellent coverage of the upper hemisphere. The flight engineer, sitting adjacent to the radio operator, operated this turret while also monitoring engine performance, fuel management, and system status during missions. German bombers lacked anything comparable to this powered dorsal turret. Most Luftwaffe bombers relied on manually operated gun positions, requiring the gunner to physically aim and fire while exposed to wind, blast, and temperature extremes. The American-powered turret allowed the gunner to remain enclosed, using hand controls and computing sight to track targets with mechanical precision. The waist positions, one on each side of the fuselage, demonstrated American approach to beam defense. Flexible half-inch guns mounted on ring supports allowed wide traverse in both azimuth and elevation. Waist gunners stood in open windows where they endured temperatures far below zero at operational altitudes, hurricane-force winds from the openings, and constant engine noise that made communication difficult despite intercom systems. But the defensive capability justified the harsh working conditions. Attacking from beam angles meant flying through crossfire from both waist positions plus the dorsal turret, which could rotate to engage targets anywhere above the horizontal plane. This concentration of fire forced German fighters to make high-speed slashing attacks rather than sustained gun runs, limiting time on target and reducing accuracy. The Sperry ball turret beneath the fuselage represented perhaps the most remarkable piece of defensive equipment German engineers examined. This rotating sphere, positioned entirely outside the fuselage and retracting into the bomb bay when not in use, provided complete coverage of the lower hemisphere with no blind spots. The ball turret gunner, cramped in impossibly confined quarters with knees drawn to chest and oxygen mask pressed against the optical sight, could track targets through 360 degrees of azimuth and nearly 90 degrees of elevation from horizontal to nearly straight down. The physical demands proved severe. The position was too small for parachutes, too cramped for much movement, and required the gunner to remain curled in fetal position for hours during long missions. Temperature at operational altitude approached 60 degrees below 0 Fahrenheit. Frostbite represented constant danger despite heated flight suits. The psychological stress of hanging beneath the aircraft in a plexiglass sphere while anti-aircraft shells exploded nearby tested even experienced gunners. But the defensive capability was unmatched by any other position aboard the bomber. No angle of approach from below escaped the ball turret's field of fire. German pilots quickly learned through bitter experience that attacking from beneath a B-24 formation meant exposing themselves to concentrated fire from multiple ball turrets, each tracking their approach with mechanical precision. The tail turret commanded rearward approaches, traditionally the most common attack angle for German fighters. Consolidated A6 design mounted two half-inch guns in powered turret with excellent visibility through clear plexiglass panels. The tail gunner position, though isolated at the extreme rear of the fuselage, with difficult access requiring the gunner to crawl through a narrow tunnel, provided clear field of fire directly aft with no blind spots above, below, or to either side within 30 degrees of the tail axis. German fighter pilots attacking from directly behind the Liberator faced concentrated fire from the tail turret, plus potential support from waist gunners and the dorsal turret if it could swing rearward. The closing speed between attacking fighter and fleeing bomber, typically around 150 to 200 miles per hour differential, gave the German pilot perhaps 3 to 5 seconds of firing time before breaking away to avoid collision. During those few seconds, the bomber's gunners poured hundreds of rounds into the approach corridor, creating a cone of fire the fighter had to penetrate. Luftwaffe combat reports documented deadly effectiveness of this defensive arrangement, with numerous fighters damaged or destroyed during tail attacks. For 4 months following arrival at Rechlin in June 1943, Blonde Bomber II remained grounded while teams of specialists conducted comprehensive examination. Every system received detailed documentation. The electrical network with its miles of wiring revealed American approaches to aircraft systems integration. The hydraulic controls showed sophisticated valve designs and pressure regulation. The oxygen distribution system demonstrated American understanding of high-altitude operations. The intercom system provided clear communication despite engine noise. The fuel management system allowed pilots to shift fuel between multiple tanks to maintain proper center of gravity as fuel burned during missions. The engine synchronization system reduced pilot workload while maximizing performance. Each component was photographed from multiple angles, sketched in detailed technical drawings, measured with precision instruments, and compared to equivalent German systems. Luftwaffe aeronautical engineers found much to admire and little to criticize from purely technical perspective. The B-24 represented mature engineering executed with manufacturing excellence that integrated available technologies into coherent weapons system. The Davis wing provided exceptional efficiency despite handling trade-offs. The modular fuselage construction facilitated mass production. The defensive armament created interlocking fields of fire that made attacks extremely hazardous, but aspects of the bomber's design troubled German evaluators who understood strategic implications. The production techniques visible throughout the aircraft's construction suggested industrial capacity operating at scales Germany had never achieved. Standardized components indicated sophisticated quality control across multiple manufacturing facilities. Smooth finishes reflected attention to aerodynamic detail. Careful assembly showed systematic production methods rather than improvisation. In September 1943, preparations began for the first flight evaluation. German mechanics completed thorough inspection of engines, testing each Pratt & Whitney R1830 radial engine on ground stands before approving them for flight. Fuel tanks were topped with German aviation gasoline. Control surfaces received detailed inspection. Hydraulic systems were pressure tested. Electrical systems were verified operational. German test pilots studied the instrument panel carefully, learning the layout and function of each gauge and control. The cockpit arrangement differed significantly from Luftwaffe practice in both organization and philosophy. American designers favored centralized panels with standardized gauge positions that remained consistent across different aircraft types, allowing pilots to transition between aircraft more easily. Circuit breakers replaced fuses in the electrical system, providing resettable protection that simplified troubleshooting. Hydraulic pressure indicators used different scales calibrated in pounds per square inch rather than kilograms per square centimeter. The throttle quadrant operated with reversed logic compared to German aircraft, with forward motion increasing power rather than decreasing it. On the fourth test flight attempt, disaster struck. As the B-24 touched down on Rechlin's grass field after a successful evaluation sortie, the nose wheel collapsed under landing loads. The bomber's forward fuselage dropped to the ground, propellers digging furrows in the turf as the aircraft slid to a halt. Damage proved substantial. The nose wheel assembly required complete replacement. Structural repairs to the forward fuselage demanded extensive work. Propellers needed replacement or major overhaul. But replacement parts for American bombers did not exist in German supply systems. Every component had to be fabricated from scratch or improvised from available materials. Skilled German craftsmen could manufacture replacements given sufficient time and resources, but both were increasingly scarce by fall 1943 as Allied bombing intensified against German industrial centers. Blonde Bomber II sat damaged at Rechlin through the remainder of 1943 and into 1944. Plans to transfer the aircraft to Kampfgeschwader 200 for operational service never materialized. The Special Operations Unit already operated several other captured B-24 that had arrived in better condition. In April 1945, as Soviet forces advanced from the east and American forces from the west, Rechlin became a target. On April 10, 170 bombers from the 8th Air Force, including 11 B-17 Flying Fortresses and 159 B-24 Liberators, struck the testing facility in massive daylight raid. The irony was unavoidable. B-24 Liberators attacking the facility where German engineers had spent years studying captured B-24. Allied personnel entering Rechlin after German surrender found Blonde Bomber II on the ramp in heavily damaged condition. destroyed by American bombs at the facility where it had taught the Luftwaffe so much about American defensive firepower and industrial capacity. But by then, numerous other captured B-24 Liberators had made their way to Rechlin, providing German technical intelligence with multiple examples of different production blocks and variants. Each newly captured bomber provided fresh opportunities for detailed examination. Engineers compared B-24D, G, H and J models, looking for evolutionary changes that might indicate vulnerabilities or improvements requiring new German countermeasures. On June 9, 1944, navigational error caused B-24G serial number 42-78106, nicknamed Cherry II by its American crew, to land at Fusach glider field near the Swiss border. The crew, part of the 460th Bombardment Group based in Italy, had become separated from their formation during a mission against Munich. Disoriented and low on fuel, they mistook the German field for nearby Swiss territory where internment awaited but also safety. German recovery specialists recognized the prize immediately. This G-model Liberator incorporated improvements over the earlier D model, including powered nose turret that addressed the frontal vulnerability that German tactics had exploited ruthlessly. Within days, the bomber received Luftwaffe codes NF plus FL and began service as training aircraft at Vernuchen, allowing German fighter pilots to study the Liberator firsthand and practice attack approaches. Multiple other B-24 seconds fell into German hands during 1944 as the strategic bombing campaign intensified. Some force landed in occupied territory after suffering battle damage. Others became lost in weather and descended through clouds to find themselves over enemy airfields rather than friendly bases. Each capture provided intelligence value, though by mid-1944 German technical staff had compiled comprehensive understanding of B-24 capabilities through accumulated studies. What these studies revealed proved far more devastating to German confidence than tactical vulnerabilities in bomber design. The strategic implications of American bomber production overshadowed any tactical lessons learned at Rechlin. Understanding the enemy's weapon did nothing to change fundamental reality. Germany could not match American industrial output regardless of how thoroughly they studied captured equipment. The numbers told the story with brutal clarity. By war's end, American industry would produce 18,482 B-24 Liberators across all variants. This made the Liberator the most produced American military aircraft in history, exceeding even B-17 production of 12,731 aircraft. No other nation approached such output. Ford Motor Company's Willow Run plant alone built 8,685 Liberators between October 1942 and June 1945. At peak production in April 1944, Willow Run completed one B-24 every 63 minutes, 24 hours per day, 7 days per week. 428 bombers rolled off the assembly line that month, an average of more than 14 per day. The Willow Run facility occupied 3.5 million square feet of factory space with assembly line 1 mile long, featuring a unique 90-degree turn necessitated by site constraints. The plant represented industrial organization optimized for volume production at unprecedented scale. Thousands of workers, many of them women entering industrial work for the first time, built complex 4-engine bombers using standardized procedures and specialized tooling that reduced skill requirements while maintaining quality standards. Consolidated Aircraft operated 2 major production facilities, one at San Diego and another at Fort Worth, Texas. Douglas Aircraft built Liberators at Tulsa, Oklahoma. North American Aviation produced them at Grand Prairie, Texas. Each factory was identified with production code suffix: Consolidated San Diego, CO, Consolidated Fort Worth, CF, Ford Willow Run, FO, North American, NT, Douglas Tulsa, DT. This distributed production system meant parts manufactured at one facility had to fit perfectly with components from other factories during final assembly. American industry achieved this through standardization of dimensions, tolerances, and assembly procedures across the entire production network. Jigs and fixtures ensured consistent dimensions, Quality control verified interchangeability. The result was a production system that could manufacture 18,000 bombers in less than 3 years, while simultaneously building hundreds of thousands of other aircraft for global operations. German four-engine bomber production never approached these figures, despite possessing advanced aviation industry at war's start. The Heinkel He 177, Germany's only operational four-engine heavy bomber, suffered chronic engine problems from its unusual coupled engine design. Total production barely exceeded 1,100 aircraft between 1942 and 1945. Operational availability remained so poor that many Luftwaffe units refused the type, preferring twin-engine medium bombers despite inferior range and bomb load. Germany simply could not match American heavy bomber production in either quantity or quality, a failure rooted in strategic decisions, industrial organization, and resource limitations. The defensive firepower that so impressed German test pilots examining captured B-24 seconds was merely the visible manifestation of deeper American advantages in industrial organization, resource allocation, and economic mobilization. Understanding the bombers' 10 machine guns and their fields of fire did nothing to answer the fundamental question. How do you stop thousands of bombers when you lack fuel, pilots, and industrial capacity to sustain the fight? The evidence mounted throughout 1944 as German fighter losses climbed to unsustainable levels. American bomber formations grew larger with each passing month. Escort fighters, particularly the P-51 Mustang with range sufficient to accompany bombers throughout their missions, made every interception costly. Luftwaffe pilot training programs struggled to replace experienced aviators lost in combat. Fuel shortages grounded aircraft that might have flown defensive missions. By summer 1944, Luftwaffe day fighter forces were losing 30 to 40% of their strength monthly. Replacement pilots arrived from training schools with perhaps 150 hours total flight time, sometimes as little as 30 hours in type. These novices faced American bomber crews with hundreds of combat hours and fighter escorts flown by increasingly experienced pilots. The attrition mathematics were brutally simple and impossibly one-sided. Germany needed to shoot down 5 or 6 bombers for every fighter lost just to maintain parity in loss rates. But American industry replaced lost bombers faster than Germany destroyed them, while German industry struggled to replace fighters at rates matching combat attrition. The Americans could sustain current loss rates indefinitely. Germany could not. Captured B-24 Liberators at Rechlin became unwitting symbols of Germany's strategic predicament. German engineers could study every system, understand every design decision, document every technical detail. They could develop tactics to attack the formations more effectively. They could train fighter pilots on captured examples to perfect approaches and firing solutions. But this hard-won knowledge proved strategically irrelevant against the reality of 1,000-bomber raids escorted by hundreds of fighters. Individual German pilots continued achieving remarkable success against B-24 formations throughout the war. Some aces shot down dozens of bombers using perfected techniques. But heroic individual performance could not compensate for systematic industrial inferiority and numerical disadvantage. The question haunting German planners by late 1944 was not whether they could develop tactics to defeat B-24 formations. They had developed such tactics through painful experience. The question was whether Germany possessed sufficient resources to sustain defensive operations against bomber streams that grew larger every month, while escort fighters made every interception more costly. The answer, evident to anyone who studied production statistics and loss rates objectively, was no. Germany could not win an attrition war against American industrial capacity. Every day the war continued. American factories produced more bombers, more fighters, more ammunition, more fuel. German production struggled under constant Allied bombing, resource shortages, and labor constraints. The captured liberators taught German engineers much about American bomber design and defensive tactics, but they also taught harder lessons about industrial capacity and strategic staying power. Examining a single B-24 revealed American manufacturing philosophy and production techniques. Confronting thousands of B-24 seconds in combat revealed the impossibility of Germany's strategic position. The systematic examination of captured B-24 Liberators at Rechlin throughout 1943 and 1944 provided Luftwaffe technical intelligence with comprehensive understanding of American heavy bomber capabilities. But understanding capabilities did nothing to create resources necessary to counter them. Knowledge of the enemy's advantages could not eliminate those advantages when they were rooted in fundamental disparities of industrial capacity. Consider the specific details German test pilots calculated at Rechlin regarding B-24 defensive firepower. A single B-24D carried 10 Browning M2 machine guns of half-inch caliber. Later H&J models maintained similar armament with improved turret designs. Each gun fired standard half-inch BMG ammunition at 750 to 800 rounds per minute. The typical ammunition load for a B-24 totaled approximately 11,000 rounds distributed across all gun positions, according to carefully calculated schemes, balancing defensive coverage with weight considerations. The nose positions, including cheek guns on D models and powered turrets on later variants, held approximately 400 rounds per gun. The dorsal turret carried similar quantities, allowing the top gunner to engage targets over extended periods. The ball turret, despite severe space constraints in the cramped sphere, held between 250 and 500 rounds per gun, depending on mission requirements. The waist positions each carried 600 to 800 rounds for their flexible guns. The tail turret ammunition load ranged from 500 to 600 rounds per gun, sufficient for sustained engagement of pursuing fighters. When German test pilots calculated combined firepower of a single B-24, firing all guns simultaneously at a target, the numbers proved staggering. 10 guns at 750 rounds per minute each produced combined rate of fire approaching 7,500 rounds per minute across all positions. Translated to rounds per second to better understand immediate tactical effect, a fully engaged Liberator could throw approximately 125 heavy machine gun bullets into surrounding airspace every second, creating cone of fire that filled approach corridors with lethal projectiles. But American bombers never flew alone over enemy territory. The entire concept of American daylight strategic bombing, developed through pre-war doctrine and refined through painful combat experience in 1942 and 1943, relied on massed formations where multiple bombers provided mutual defensive fire that dramatically increased firepower any single attacking fighter would face. The combat box formation, developed by American commanders and refined through bloody experience over Germany, positioned bombers in tight three-dimensional arrays where each aircraft's guns could support its neighbors. A squadron element typically contained 3 aircraft flying in close formation, V or echelon, depending on tactical situation. 3 squadron elements, stacked vertically and offset horizontally, formed squadron box of 9 bombers. 3 squadron boxes formed group box of 27 aircraft, though some groups flew with 4 squadrons for total of 36 bombers. A typical 3-squadron group box contained 18 to 27 aircraft, depending on attrition and maintenance status. If each bomber carried even 10 guns, the group's combined defensive armament exceeded 180 to 270 heavy machine guns, providing interlocking fire. 3 such groups combined to form wing box with 54 to 81 bombers and 500 to 800 machine guns, creating zones where attacking fighters faced concentrated fire from dozens of bombers simultaneously. German fighter pilots attacking such formations described approaching wall of tracers, vivid description capturing both visual and psychological impact of mass defensive fire. At typical combat ranges of 400 to 800 yards, every bomber gunner who detected attacking fighter opened fire simultaneously, creating visual spectacle that was both beautiful and terrifying. 50 or more machine guns might concentrate fire on single fighter, making head-on pass through the formation, with each bomber's gunners tracking the target and firing at maximum rate. The psychological impact overwhelmed many pilots regardless of actual hit probability, which remained relatively low due to difficulties of deflection shooting, range estimation, and brief time available for engagement. Luftwaffe after-action reports documented numerous instances of fighters breaking off attacks prematurely before reaching optimal firing range, because pilots could not force themselves to fly deeper into the defensive barrage. Those pilots who maintained formation discipline and pressed attacks home despite defensive fire faced brutal arithmetic favoring the defenders. Luftwaffe studies conducted using data from actual combat engagements determined that attacks on B-24 seconds from any angle required average of 20 to 25 hits from 20mm cannon shells to destroy a bomber, assuming hits were distributed across vulnerable systems rather than concentrated in one area. The B-24's construction, while not as legendarily rugged as the B-17 Flying Fortress, still incorporated structural strength through heavy-gauge aluminum alloy frames and stressed skin construction. Multiple redundant systems meant single failures rarely proved catastrophic. Self-sealing fuel tanks prevented fires from small-caliber hits. Armor plate protected critical crew positions and vital systems. Average German pilot accuracy against evasive targets at combat ranges ran approximately 2 to 3%, figure determined through analysis of gun camera footage and ammunition expenditure reports. Therefore, destroying single Liberator from any approach angle required firing approximately 800 to 1,000 rounds of 20mm ammunition to achieve the 20 to 25 hits needed for a kill. Early model Focke-Wulf FW-190 fighters carried approximately 500 rounds, total of 20mm ammunition distributed across 2 wing-mounted cannons, each gun holding 250 rounds in drum magazines. Later variants with 4 cannons and belt-fed ammunition provided only 500 to 600 total rounds across all guns, still insufficient for multiple sustained attack runs. Even with upgraded armament, a German fighter pilot might have ammunition for 1, perhaps 2 gun runs before exhausting cannon ammunition and being forced to break off and return to base for rearming. Meanwhile, the bombers continued toward their targets, their thousands of rounds of half-inch ammunition allowing prolonged defensive engagement throughout the mission. While individual bomber gunners achieved relatively low hit percentages due to difficult deflection shooting at extreme ranges and high closure speeds, the sheer volume of fire made hits statistically inevitable when dozens of bombers engaged single target. Luftwaffe fighter losses climbed steadily through 1943 and into 1944 as American bomber streams grew larger and more frequent, while German fighter forces struggled to regenerate losses faster than combat attrition destroyed them. The captured B-24 seconds at Rechlin allowed German fighter pilots to study their targets intimately in ways impossible through combat experience alone. They walked completely around the Liberators, examining them from every angle and noting gun positions and fields of fire. They climbed inside through fuselage hatches, crawling through cramped interior, and experiencing limited space and difficult working conditions bomber gunners endured. They sat in various gun positions, testing traverse and elevation limits, while noting blind spots where attacking fighters might evade defensive fire if they approached from specific angles. They flew formation exercises where captured bombers took evasive action while German fighters practiced approach angles and firing solutions, creating training scenarios that transferred directly to combat. This training proved invaluable for experienced pilots who learned to exploit B-24 vulnerabilities through systematic study. Frontal attacks from 12 o'clock high offered best chance of success by minimizing exposure time and targeting weakest defensive zone. But by late 1943, the Luftwaffe was losing experienced pilots faster than training programs could replace them with equally skilled aviators. New pilots straight from flight schools lacked hundreds of hours of experience needed to execute complex attack maneuvers under fire while maintaining situational awareness. They often broke off attacks prematurely or pressed them too aggressively, either wasting ammunition or dying in collisions with bombers they attacked. Additionally, the Americans continuously improved their bombers based on combat experience and crew feedback. The B-24H model entering service in summer 1943 added powered nose turret, mounting 2 half-inch guns that could engage targets directly ahead. This Emerson-designed turret significantly improved bombers' frontal defensive capability against head-on attacks that had proved effective against earlier models, with only flexible nose guns. The nose turret could track attacking fighter throughout its approach from first detection at long range, concentrating fire along predicted intercept path. Combined with existing cheek guns and dorsal turret which could swing forward, a B-24H could bring 6 to 8 heavy machine guns to bear on frontal attacker, creating defensive cone requiring exceptional skill to penetrate. This forced Luftwaffe to adapt tactics once again, searching for new solutions to evolving defensive problem. Some fighters attacked from high angles, diving from above and ahead at steep angles where bomber guns had limited elevation traverse. Others approached from below the nose, hoping to stay under nose turrets' depression limits while avoiding ball turret. Still others resorted to standoff weapons, launching unguided rockets from beyond machine gun effective range. The Werfer Granit 21cm rocket became favored weapon among German fighter units. These unguided projectiles, launched from tubular launchers mounted under wings, carried large, high-explosive warheads intended to break up bomber formations through blast effect rather than achieve direct hits. Actual hit probability remained low due to rockets' poor ballistic characteristics, but rocket exploding amid combat box could damage multiple bombers simultaneously through blast and fragmentation or cause collisions as pilots took violent, evasive action. But standoff attacks carried serious problems limiting effectiveness. The rockets were inaccurate beyond 800 yards, heavy enough to significantly reduce fighter performance, and created substantial drag, making launching fighter vulnerable to Allied escort fighters. Pilots carrying underwing rocket tubes became easy targets for American P-51 Mustangs and P-47 Thunderbolts, which by 1944 included long-range variants capable of accompanying bomber formations throughout their missions, eliminating sanctuary German fighters had previously enjoyed in depths of German airspace. The technological race continued throughout 1944 as both sides sought advantages. The Luftwaffe developed heavier cannons including 30mm Mk108 weapons that could destroy bombers with few hits. The Americans improved defensive armament and perfected formation tactics through experience. But one inescapable reality dominated the equation. American industry could replace losses faster than German industry, despite operating across Atlantic Ocean and shipping everything to Europe. Production statistics told story of overwhelming material advantage. German intelligence analysts understood, but could do nothing to counter. 18,482 B-24 Liberators built between 1939 and 1945, with overwhelming majority produced during peak war years of 1943 through 1945. Ford's Willow Run plant alone built 8,685 Liberators. Consolidated's two plants contributed approximately 7,000 more. Douglas, North American, and other contractors added remaining production. Peak production in 1944 saw Ford alone building approximately 430 Liberators per month, more than 14 per day from single manufacturing facility. This rate seemed impossible to German observers, but was verified through multiple intelligence sources, including interrogation of captured American aircrew, reconnaissance photographs of American industrial centers, and examination of captured bombers showing consistent quality despite massive production volumes. German four-engine bomber production never approached these figures. Total Heinkel, He-177 production barely exceeded 1,100 aircraft across all variants. Germany simply could not match American heavy bomber production in either quantity or quality. Failure rooted in strategic decisions made years earlier, industrial organization optimized for different purposes, and resource limitations that worsened as war progressed. When Luftwaffe pilots learned production statistics through intelligence briefings, attempting to prepare them for scale of opposition they would face, morale suffered among thoughtful aviators who understood implications. What was point of risking lives to shoot down one Liberator when 10 more would replace it within week? The question haunted fighter squadrons across Germany as strategic situation deteriorated through 1944. The captured B-24 seconds at Rechlin had provided German engineers with detailed understanding of American manufacturing methods, explaining how such production rates were achieved. They studied modular construction, allowing sub-assemblies built at different factories to fit together perfectly during final assembly. They examined standardized components, sourced from hundreds of subcontractors nationwide, creating supply chain of unprecedented complexity and efficiency. They analyzed simplified assembly sequences, allowing semi-skilled workers to build complex bombers in fraction of time experienced German craftsmen required. German reports from these studies expressed grudging admiration for American industrial organization, while noting impossibility of Germany matching such methods given current constraints. The B-24 represented more than individual engineering excellence. It represented complete manufacturing philosophy, prioritizing production volume over artisanal quality, emphasizing interchangeable parts over custom fitting, accepting adequate quality over perfection. Every design decision reflected this philosophy. Standardized fasteners throughout aircraft reduced inventory requirements and simplified assembly. Relatively straight panels with minimal compound curves simplified forming operations and reduced scrap rates. Modular sub-assemblies allowed parallel construction of fuselage sections, wings, and tail surfaces that came together in final assembly with minimal fitting required. This approach enabled Ford's Willow Run plant to complete one B-24 every 63 minutes at peak production rates, feat that seemed impossible to German observers accustomed to production rates measured in weeks per aircraft. German factories using traditional aircraft construction methods with custom-fitted components, hand-riveted assemblies, and skilled craftsmen performing most operations required weeks to build single bomber. The implications were strategic and inescapable to anyone understanding industrial production. Even if German fighters achieved favorable loss ratios in combat, even if they shot down 2 or 3 bombers for every fighter lost, American industry could sustain such attrition indefinitely, while German industry could not. By mid-1944, this reality became undeniable even to most optimistic German commanders. The question was no longer whether Germany could win air war over Europe. The question became, how? Long German forces could continue fighting against increasingly overwhelming material disadvantage before collapse became inevitable. The defensive firepower concentrated in B-24 Liberators represented only one aspect of comprehensive system designed to project American strategic bombing capability deep into enemy territory, despite determined opposition. The bomber combined long range exceeding 2,000 miles, high-altitude capability above 30,000 feet, heavy bomb load of 4,000 to 8,000 pounds depending on mission requirements, and devastating defensive armament into single package that, when multiplied across hundreds of aircraft flying in mutually supporting formations, created aerial weapon fundamentally changing nature of warfare. Luftwaffe General Adolf Galland, one of Germany's most successful fighter aces with 104 confirmed victories and eventual commander of German fighter forces, wrote extensively in post-war years about challenges of defending against American daylight bombing. He acknowledged that individual German pilots often possessed superior training and more extensive combat experience compared to many American bomber crews on their first combat tours. German fighters, particularly late-war models like Focke-Wulf FW-190D9 long-nose variant and Messerschmitt Bf-109K4, could outperform B-24 seconds in every performance metric, including speed, climb rate, and maneuverability. German cannons hit far harder than American half-inch machine guns, delivering explosive shells that could destroy bombers with few hits. Yet, despite these advantages in equipment and pilot skill, German fighters could not stop daylight bombing campaign that systematically destroyed German industrial capacity. Galland attributed this failure to multiple factors in post-war writings, but American industrial capacity topped his list of decisive factors. The Americans simply built more of everything faster than Germany, could destroy it, whether bombers, fighters, tanks, or any other war material. The captured B-24 seconds proved this reality beyond doubt for German engineers and planners who studied them. German technical staff dismantled systems, studied components, evaluated design decisions with thoroughness impressive to any investigator. They found much to admire in bombers' design and little to criticize from pure engineering perspective. The Liberator represented mature engineering executed with manufacturing excellence, integrating best available technologies into coherent weapons system. But no amount of tactical innovation or pilot skill could compensate for such material disparity in war of attrition. The B-24's defensive armament served as critical enabler for daylight strategic bombing mission. Without those machine guns and interlocking defensive formations they made possible, daylight operations would have proven impossible, regardless of how many bombers Americans built. German fighters would have slaughtered unescorted bombers in numbers, forcing Americans to abandon daylight operations and switch to night bombing like British, reducing accuracy and effectiveness. The defensive firepower did not make bombers invulnerable or prevent losses. Thousands of B-24 seconds were shot down over Europe by determined German fighter pilots and accurate anti-aircraft fire. But the defensive armament made them survivable in sufficient numbers to accomplish mission over time. Enough bombers got through defenses to hit targets. Enough crews survived their tours to return home and train new crews. The cumulative effect of hundreds of bombing missions over 2 years systematically destroyed Germany's industrial capacity, oil production facilities, transportation networks, and military production capabilities. By 1945, German industry lay in ruins across Ruhr Valley and other industrial centers. Fuel shortages grounded much of Luftwaffe despite having aircraft available. Transportation chaos prevented delivery of critical supplies to front lines. The story of captured B-24 Liberators in German service represents curious footnote to larger narrative of strategic bombing campaign over Europe. These aircraft, built in American factories by American workers, flown by American crews on combat missions, shot down or forced down by German forces, then rebuilt and flown by German pilots, served as unique windows into Allied capabilities and American industrial methods. They revealed strengths Luftwaffe needed to counter through new tactics and weaknesses that could be exploited by skilled pilots. They trained fighter pilots in aircraft recognition and attack procedures. They supported special operations missions deep behind enemy lines. They contributed to German war effort in numerous ways throughout 1943 and 1944. Yet ultimately they also demonstrated impossibility of Germany's strategic position by revealing scale of American industrial capacity. Every hour, German technicians spent repairing captured American aircraft represented skilled labor diverted from maintaining German aircraft. Every gallon of precious fuel burned testing enemy bombers was fuel unavailable for combat operations. Every bullet fired during evaluation exercises represented ammunition Germany could not spare. Meanwhile, American factories produced more B-24 seconds every day, replacing losses faster than combat could inflict them. The production statistics remain staggering 8 decades after war's end. 18,482 Liberators built by September 1945 made it most produced American military aircraft in history. Each bomber was a complex machine containing approximately 40,000 individual parts manufactured by hundreds of subcontractors. 4 Pratt & Whitney engines producing 1,200 horsepower each, miles of electrical wiring, thousands of pounds of aluminum, and that formidable defensive armament. The reasons for dramatic production disparity between American and German heavy bombers extended far beyond simple industrial capacity or factory floor space. American strategic doctrine prioritized heavy bombers for deep penetration missions, while Germany focused on medium bombers and dive bombers, optimized for close air support of ground forces, fundamental difference in military philosophy. American geography, protected by vast oceans enemy forces could not cross, allowed undisturbed factory expansion and operation, while German industry operated under constant Allied bombing, destroying facilities, killing workers, and disrupting supply chains. American engineering education produced thousands of skilled designers, managers, and technicians annually, while Germany struggled with manpower shortages as war dragged on and casualties mounted. Most fundamentally, American political and economic systems proved more adaptable to total war mobilization than rigid Nazi hierarchy with competing power centers, inefficient decision-making, and ideological constraints. All these factors combined to create industrial advantage determining strategic outcomes. The B-24 Flying Fortress represented just one weapon in America's vast arsenal, but it symbolized entire apparatus of American war production. When Luftwaffe officers stood before captured liberators at Rechlin, studying construction, testing systems, flying evaluation missions, they were really studying American industrial civilization and its capacity for sustained production. What they learned should have been obvious from beginning to anyone studying American industrial capacity objectively. You cannot defeat enemy who can build bombers faster than you can shoot them down, who can train crews faster than you can kill them, who can deliver bombs in greater tonnage than your entire nation's industrial output across all sectors. The defensive firepower that impressed German test pilots was merely visible manifestation of deeper American advantages in industrial organization, resource allocation, and economic mobilization. The real secret weapon was not 10 machine guns mounted on B-24, it was economic and industrial system that could design, manufacture, and deploy 18,000 of these bombers, while simultaneously building 300,000 aircraft of all types, 88,000 tanks, 41 billion rounds of ammunition, and everything else needed to fight global war on multiple fronts. No amount of tactical brilliance, pilot skill, or individual courage could overcome such overwhelming disparity in industrial output. Hans Werner Lerche, after flying dozens of captured Allied aircraft and seeing first-hand quality and quantity of enemy equipment, concluded that Germany had already lost the war by 1943 based purely on industrial mathematics. The mathematics of material production predicted defeat with mathematical certainty. The captured B-24 seconds at Rechlin answered some important tactical questions for German fighter pilots. They revealed blind spots in defensive coverage that skilled pilots could exploit. They identified vulnerable systems that could disable bomber. They demonstrated attack profiles, offering best chance of success. But they could not answer fundamental strategic question determining outcomes. How do you stop 10,000 bombers when you can barely build 1,000 fighters annually? How do you defend cities against endless raids when your pilots fly 3 or 4 missions per day until they are killed, wounded, or too exhausted to continue? How do you maintain industrial production when every factory worker knows American bombs will eventually find their workplace? These questions had no satisfactory answers within framework of Nazi Germany's war strategy and industrial organization. The regime had started war of conquest, assuming quick victory before enemies could fully mobilize economies and industrial capacity. When that fundamental assumption proved false, when war became grinding contest of industrial attrition and staying power, Germany's fate was sealed by decisions made in 1930s. The B-24 Liberator, with its multiple heavy machine guns, its ability to absorb horrific damage and continue flying, its clear manifestation of American industrial capability and organizational efficiency, represented not just tactical challenge but strategic verdict on war's outcome. The bombers came every day in increasing numbers. The fighter escorts grew more numerous and capable. The targets burned systematically. And there was nothing Luftwaffe could do to stop campaign despite heroic individual efforts. German test pilots at Rechlin flew captured B-24 seconds extensively and came away with grudging respect for American engineering, manufacturing, and military organization. They admired bombers' thoughtful design, prioritizing crew survivability and operational effectiveness. They acknowledged its devastating defensive firepower, making formation attacks deadly proposition, but respect for weapon did nothing to change outcome of battles in sky over Europe. Knowledge of enemies' capabilities could not create resources needed to defeat them when those resources simply did not exist in sufficient quantities. By late 1944, the war's outcome was beyond doubt to anyone who understood industrial mathematics and loss rates. The captured liberators had taught Luftwaffe everything they needed to know about B-24 as weapons system. They understood its strengths, including rugged construction and heavy defensive armament. They knew its weaknesses, including relatively difficult handling characteristics and vulnerability to determined attacks. They had documented its capabilities in terms of range, altitude, bomb load, and formation flying. But this knowledge could not change fundamental arithmetic of industrial production determining strategic outcomes. For every German, Pilot who learned to attack B-24 seconds effectively through training at Rechlin or combat experience, Americans trained 10 new bomber crews. For every Liberator shot down over Germany through superior German tactics, American factories built 5 more bombers. For every successful interception disrupting bombing raid, dozen more raids flew next week with even larger formations. The different approaches to crew utilization reflected different industrial realities and strategic positions. America could afford to rotate experienced crews to training roles because production provided steady streams of replacement aircraft and new crews. Germany could not spare anyone with combat experience. Every pilot capable of flying combat missions stayed on line until killed, captured, or incapacitated, leading to declining average experience levels across fighter units. The ultimate lesson came in May 1945 when guns finally fell silent across Europe. Germany lay in ruins, cities destroyed, industry shattered, military crushed between Soviet forces in east and Western Allied armies in west. The bombers had done their work over 2 years of sustained operations. The defensive firepower that impressed German test pilots in 1943 had proved sufficient for Liberators to complete mission, despite taking terrible losses. The story ends where it began, in sky over Europe, where men fought and died in machines representing their nation's industrial capabilities, strategic doctrines, and approaches to warfare. Blonde Bomber II, the first intact B-24 captured by Axis forces, served as unwitting teacher from February 1943 when it landed at Pacino until April 1945 when American bombs destroyed it at Rechlin. During those 2 years, it taught German aviators and engineers volumes about American bomber design, defensive tactics, and industrial capabilities. The lessons proved intellectually valuable but strategically irrelevant to changing outcomes. Understanding your enemy's advantages does not eliminate them or create counters when resources do not exist. The 10 machine guns that impressed test pilots at Rechlin represented not just defensive armament, but American industrial philosophy made tangible: overwhelming firepower through volume of fire, mutual support through formation tactics, redundancy through multiple weapon systems, all designed to ensure enough bombers survived each mission to destroy targets and return home to fly again. This philosophy worked despite heavy costs. Despite losing thousands of B-24 seconds to all causes during war, including combat losses, operational accidents, and weather. Despite casualty rates among bomber crews exceeding 20% in some units during 1943. Despite German fighter opposition shooting down hundreds of Liberators in determined resistance, the strategic bombing campaign succeeded in its objectives. Germany's war industries were destroyed, its cities burned, its transportation networks collapsed, and when war ended, American factories were still building B-24 seconds at rates that would have allowed complete replacement of all combat losses within 6 months, demonstrating ultimate futility of trying to win attrition war against American industrial capacity. The captured B-24 Liberators in German service became unwitting witnesses to their own nation's defeat. Every test flight revealed American capabilities. Every evaluation report documented American advantages. Every training exercise emphasized same inescapable message. America possessed industrial capacity Germany could never match through any realistic means. The defensive firepower was impressive and merited respect. The productive capacity behind it was overwhelming and ultimately decisive. That was real lesson of captured Liberators, though it took time for all participants to fully comprehend implications. The Luftwaffe officers who flew captured B-24 seconds admitted they had never seen such concentrated defensive firepower in their experience with other bomber types. They marveled at interlocking fields of fire covering all approach angles, heavy-caliber weapons that could destroy fighters at long range, volume of ammunition allowing sustained engagement, but defensive guns were merely visible manifestation of America's true weapon. The arsenal of democracy operating at full capacity proved unstoppable despite determined resistance. The Liberators came in their thousands, the bombs fell on their targets, and Germany fell with them. The captured B-24 seconds could teach tactics and reveal vulnerabilities. They could not change strategic destiny determined by industrial capacity. That lesson, learned at such terrible cost by millions, remains relevant 8 decades later as reminder that modern warfare is as much industrial contest as military one, and that quantity, when backed by adequate quality, becomes quality of its own. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.